All right, everybody, this is going to be the lecture for homework 12. Luckily, not a long one, probably something you'll be familiar with for the most part. Just some definitions and just some basic algebra. So hopefully you'll find this one to be pretty light. Let's see, homework 12. The topic here is going to be evaluating expressions and functions. All right. Now, you already know how to do this. That's the thing. Evaluating expressions part is something you're familiar with already. You may not be familiar with it under that term, but you have done this before. A couple vocabulary words before we get going. I think we've even mentioned some of these. A constant, that's like a number, like 3 or -10 or 1/2, right? The value of 3 is fixed. It doesn't change. The value of -10 is fixed. It doesn't change. The value of 1/2 is fixed. It doesn't change. Now, variables x, y, a, b, you can get into like Greek letters like theta, whatever. They have variable value. They stand for various different things, right? X could be 10 in one problem. It could be -11 in another problem. We call those variables. A couple other terms you would want to know. Expression versus an equation. For the most part, we'll be working with expressions in that they don't have an equal sign, or they're equal to what you're supposed to find, not equal to a value. So something like this, 2x minus 4y, that's an expression because there's no equal sign, right? Or, 7x squared plus 10x minus 3. That's an expression. There's no equal sign. If I tell you to plug something in for x, you might tell me what it's equal to, but there is no equal sign to start with. There's no two sides, right? An equation has, two sides. And then you balance them and try to solve for one of the variables. So they're not exactly the same thing, right? Be a little bit careful here. Expressions and equations, not the same thing. Expressions are what you evaluate, meaning I tell you what to put in for x or y or whatever, and you give me a value, you evaluate it, okay? And so that's what we're doing. And then don't forget the numbers, the constants, I guess you could say, that are in front of variables are called coefficients. Just a good word to know. That 2 is the coefficient of x, that 4 is the coefficient of y. Over here, the 7 is the coefficient of x, and the -4 is the coefficient of x on this side. So just be aware of those kind of terms, okay? But the main idea in the homework is the evaluation. So let's just say to start off with something not too crazy. I told you to evaluate x squared plus 4x plus 7, right? And then over here, we'll just tell you x is 2. So when I give you the value of 2, I want you to evaluate the problem and tell me what its value would be when x is 2. One thing I would strongly suggest, and you'll see why later, put parentheses when you plug in, not around anything but the variable, not around the power, not around the signs, not around the coefficients, nothing, just around the x, and then plug in. In fact, if you want to do a separate step, put the x's in parentheses and then plug directly into the parentheses, just to avoid, order of operations errors, things like that. So 2 squared here is 4. Remember, exponents first. Then we'll do multiplication. 4 times 2 is 8, plus 7. 4 and 8 is 12, plus 7. This is 19, okay? So this evaluated when x was 2 to the value of 19. So again, you're just plugging in variables. I mean, it's nothing crazy, guys. You've done this stuff before, okay? So we'll just do some examples. There's a few little nitty-gritty things to talk about, but this will be a pretty short lecture. Hopefully y'all can knock this homework out pretty quickly. It's more just a matter of practicing your computation. Okay, so let's do another one here, a little more complicated one. And some of these formulas that they use in the homework you might recognize. Some of them will be made up. All right, so this formula here, F equals 9/5 C plus 32. This is the Fahrenheit to Celsius formula. I think they'll have you do it both ways, Fahrenheit to Celsius, Celsius to Fahrenheit. So in this case, they said, look, the Celsius is 92. The degree Celsius is 92 degrees. So what would the degree Fahrenheit be? Now, this is an equation because we do have an equal sign on both sides, but you don't know what F is. That's what we're asking you to find. So you're going to plug into all this, and then the answer will be over here. So there's not going to be any moving across the equal sign. What we're trying to find, the F, is already by itself. So you can treat this like an expression in that you don't need to go moving anything across equal signs or anything like that. So 9/5 times whatever C was plus 32. And we're told that C was 92. So what we do is just need to work this out. We'll review with fractions, right? So we have 9/5 times, and I'm gonna go ahead and just call that 92 over 1 plus 32. Now the nice thing, remember when you multiply fractions, you don't need a common denominator. You can multiply straight across. Let's see if we can get any cancellation going to make this smaller. 9 and 1 will not cancel, 9 and 5 will not cancel. Remember, any numerator can cancel with any bottom as long as they have something in common. 92 and 1 don't cancel, 92 and 5 don't cancel. So there's nothing to cancel here. We're just gonna go straight across. 5 times 1 is 5. 9 times 92, just do it off to the side. 2 times 9 is 18, carry the 1. 9 times 9 is 81, plus 1 is 82. 828 over 5. All right. Then we're going to say plus 32. So what I'm going to go do here is go ahead and say that's 825 over 5 plus 32 over 1. So now, because we're adding and subtracting fractions, we do need a common denominator. In fact, our least common denominator here would be 5. So what I'm going to do is adjust this times 5 times 5. So what we have here is 828 over 5 plus 5 times 3, that's 150. 5 times 30, rather, that's 150. 5 times 2 is 10, so that should be 160 over 5. Okay. We add those in together. We get what? 988 over 5. And now we just need to convert this to a reasonable answer, because I believe, I didn't write it down, that's my fault, but I believe the homework said it wanted decimals, round the decimal to the nearest tenth. So while this is the correct answer, we need to go ahead and convert it to decimals. Just pay attention in the homework to what the instructions say. Let's give ourselves a little bit of room here. So I'm gonna do this right here. So 988 divided by 5. Don't forget your decimal, because if they tell us there's gonna be decimals, we'll need one. 5 goes into 9 one time. 1 times 5 is 5. Subtract and we get 48. Actually, you know what? I'm going to run out of room right here. Let's back this up. I'll do it up here. A little more room up here. Sorry about that, guys. Just realized I was going to have to squeeze it in there, and with the Sharpie, it's not easy to write in fine points. We'll do it up here. 988 divided by 5. 5 goes into 9 one time. 1 times 5 is 5. Subtract. We get 4. We bring down the 8, just like where we were a minute ago. 5 goes into 48. 9 times. 9 times 5 is 45. Subtract. We get 3. Bring down the 8. Almost run out of room here. 5 goes into 38. 7 times. 7 times 5 is 35. Sorry about the mess here. We get a 3. Remember, we had a decimal. Bring down your 0. 5 goes into 30 6 times. Whew. Almost completely ran out of room there. Sorry about that, y'all. I just hate using a whole nother sheet of paper just for that. Probably should have. So we get 197.6. Let me run through that again, because that was a little confusing and all over the place. The one I did over here just simply ran out of room. You can ignore that. So what we had was 988 divided by 5. We needed to turn it into a decimal, which most of the homework problems, that is what they want. So 988 divided by 5. Put your decimal, bring it, and go. 5 goes into 9 one time. 1 times 5 is 5. Subtract, you get 4. Bring down the 8. 5 goes into 48 9 times. 9 times 5 is 45. Subtract, you get 3. Bring down the 8. And this is where it's going to get a little muddled, so make sure you're following your notes. Bring down an 8. 5 goes into 38 7 times. 7 times 5 is 35. 38 minus 35 is 3. This is where, like I said, I kind of had to cram it in there. Drop the 0, and 5 goes into 36 times. So 197.6, a nice review, because you review fraction multiplication, you review fraction addition, and then you review decimal division. So that's sort of the idea here in the homework, guys. It's not just, oh, can you plug 92 into C? Of course you can. Anybody can. The question is, can you work it out and remember all the old steps? So some of these are a little longer than others. They're not all that bad, but you should be prepared. It's not going to be necessarily just trivialities. But the material itself is not super difficult to learn. This is what I was getting at. You still have to be able to execute, right? Remember, there are 2 parts to every math problem. Knowledge, which is what I was saying, you already know. You know how to plug into a formula. The question is, can you execute it, right? So practice, practice, practice. Now, the other thing in the homework was functions. Now, the thing about functions is we're not really going to say much here. Functions. This is sort of a I'll say advanced topic, but it really isn't something you're going to mess with until college algebra. So for right now, what we want you to do is understand function notation. We're not really going to get into what's a function, how to tell if something's a function or not. We're going to give you functions, and then you're going to need to understand the notation. The easiest way to just go ahead and put this in your brain is a function is a special type of equation. A special type of equation. What is that special type? How do we know? Don't worry about it. It's not something I'm going to test you on in this class. You don't need to worry about what a function is. I can't even read that word. You don't need to worry about what a function is beyond that it's some type of equation, all right? What makes something a function, what makes an equation a function versus not a function, you'll get into that in a different class. How will you know something's a function? Well, it'll look like this. That's a function. And the way this is read, if you read it out loud, is f of x. So you say f of x equals 3x minus 10. This is just basically saying we're going to call this formula f and the variable is x. It doesn't have to be f. A lot of times it is f for function, but it can be any letter of the alphabet. You could do g of x equals x squared plus 3x plus 2. G of x equals x squared plus 3x plus 2. And all we're doing is basically saying this is the function g. And if I plug x into it, this is what it looks like. All right. So if I was to say, well, what's g of 1? And that's the notation we want you to understand. That's what it's going to look like. They're going to tell you, here's what the function is with x inside of it. We'll call it g. This is what it looks like. Here's the function g with 1 inside of it. What does that look like? All they're doing is having you replace the x with the 1. Think about it. The only thing they did here is instead of g of x, they wrote g of 1. Well, replace x with 1. So it'll be 1 squared, use parentheses. In this case, you'll get away without it, but it's going to be meaningful in a minute. So replace all the x's with 1 and just work it out. 1 squared is 1, plus 3 times 1 is 3, plus 2, 1 plus 3 plus 2, 6. So what you would say here is g of 1, the function g, when I put 1 into it, gave me 6 as the answer. So it's the same thing we were doing just a minute ago. Here's a formula, here's a number, plug it in. We just want y'all to understand what the function notation means, what it looks like. So if I said f of x equals 7x plus 9, and I asked you for f of 3, think about what it is I'm asking. Whoops, I got cockeyed. Think about what it is I'm asking, right? I'm asking you to take the function f, which is just this, and plug 3 into it for x. So it's going to say 7 times 3 plus 9, 21 plus 9. F of 3, the function, when we put 3 into it, gave us 30. So that's the beautiful thing. It really isn't different than what we were just doing. You're taking a formula, you're plugging a number into it, and you're telling me what the value is. The only difference here is they are equations because they have 2 sides. But we're telling you what to put in for the x. That's what the function notation is. F, here's the function at x, looks like this. Here's the function when you put in 3, looks like this. Work it out, okay? Nothing crazy. Just a heads up, I'll go ahead and add this in, even though this is not required for this homework, just so you know in the future. When you see f of x or g of x or anything like that, you can think about that as y. So, I mean, you could literally come down here and say y equals this or y equals that. I'm getting a little ahead of myself, but I'm just letting you know, it just for the future, f of x is the same thing as y. You don't need to worry about that for this homework, but, you know, down the road. All right? So that's function notation, nothing crazy. You're just plugging in whatever they replace for x, that's what you're plugging into the formula. Whether you're doing a function or not, there's, you know, there's some pitfalls to plugging stuff in. Whoa, I was getting away from it. Whether you're doing a function or not, or whether it's just a regular evaluation question like the ones we did earlier, you have to be careful. The ones we've done so far haven't been too crazy. But I put this one on the test last semester. And quite a few people missed it. All right. 2x squared y minus x squared, 2x squared y minus xy squared. And I want you to evaluate, okay? That would be the instructions. Evaluate. So I'm telling you x here is -2 and y is -3, so just plug them in. The issue is the order of operations, man. I mean, it's what it always is. People always have issues because order of operations is complicated, not the order itself, but, you know, how to apply the order. So remember when I said go through and do parentheses first? Parenthesis, in fact, if you want to do it here, parenthesis around the x, parenthesis around the y, parenthesis around the x, parenthesis around the y. It's a little ugly looking, that's why I don't do it up there. But and then replace. -2 went in for x. Notice the power is outside the parenthesis. The x is in parentheses, the x gets replaced, not the power. The power stays where it was. The y is in parentheses, the y gets replaced. Now we have our minus sign. The x is in parentheses, the x gets replaced. The y is in parentheses, the y gets replaced, but not the power. When you put the parentheses, they only go around whatever the variable was, not the power, not the coefficients, and not the signs. Be careful, guys. All right, now we just have to work it out. So order of operations would tell us to do what first, right? Well, grouping symbols, meaning parentheses, but look inside the parentheses. Can you do anything inside of them? Because that's what grouping symbols mean, like the parentheses. Can you do anything inside of the parentheses? In this case, not really. So next would be exponents. What do you think the most common mistake is here? The mistake that most people made. Well, what they did is they came here and they said negative and negative is positive, right? Because that's what we did early on in the class. I said, get rid of these double negatives. That's junk. Negative, negative, that's positive. And that's true if you're multiplying. But think about what I just said a second ago. The order of operations says do grouping symbols first, right? Which is done. There's nothing to do in the parentheses. The next step is the exponents, not multiplication. So if you say negative times negative right now, you skip straight to multiplication and ignore the exponents. Do things in order. First step, grouping symbols, parentheses, whatever. Second step, exponents and roots. We've gone over this several times, right? Third step, multiplication, division. Fourth step, addition, subtraction, and go left to right if they're on the same step. So we're done with the grouping. That really didn't happen. Now we're doing exponents and roots, left to right. So this 2 just sits there. Here we have -2 squared. Is the negative included or not? Well, yeah, it is, because it's in the parentheses, which is why I had you write it like that. So -2 times -2 is 4. The -3 is still there. We didn't do anything with that. We're not going to say negative and negative is positive, okay? It is, but I'm just saying if you go out of order, it could cause a problem. In fact, I'll show you one after this where if you go out of order, it would cause a problem. A -3 squared would be 9. And then we just work it out. Now we're multiplying. So now you can do your negative. 2 times 4 is 8. Times 3, that's -24. Negative and negative is positive if you want. 2 times 9 is 18. We have -24 plus 18. So that would be -6. Take a minute, make sure it makes sense to you. It's kind of a longer one, right? We said -2 squared is 4. -3 squared is 9. 2 times 4 is 8. Times -3 is -24. Negative and negative is positive. 2 times 9 is 18. -24 and 18 is -6. Okay? Now, what if, how could I change? Well, let's do the exact same problem. 2x squared y minus, actually, let's switch it up just a bit. So I'm going to take the same problem we just did, and we'll give ourselves room down here. And I'm going to say the same values. The only thing that changes is I switch the end up around a little bit, right? Instead of it being xy squared, we're going to do y squared x. And now you're going to see why the parentheses matter and why you need to be careful about order. So first thing we'll do is go ahead and just put everything back in the parentheses. Nothing crazy. Okay. Order of operations says do grouping symbols first. Nothing to do in any of the parentheses. So we're done with that. Exponents and roots next. Left to right. So that's 2. -2 is squared is 4, just like before, and the -3 still stays. The left side is exactly the same as before. Now the right side, negative and negative is positive, but we're not doing that yet. -3 squared is 9, and that's -2. So look, if you had said negative and negative is positive here, you'd have a positive 9. But you're supposed to have a -9 because that negative happens to belong to the power. So just be careful. Up here, negative and negative is multiplied, and you were able to get away with it because there was nothing on the 2. If you said negative and negative is positive here, you didn't do the exponent yet. Once you do the exponent, there is no negative. So be careful. Here we'd have 2 times 4 times -3 minus 9 times -2. So that's going to be 8 times -3. That's -24. -9 and -2 is positive 18. So this one works out to be the same answer simply just by coincidence. Okay. But my point to you is the same thing. right? Here the negatives canceled out, here negatives canceled out, but they were in different places. So be careful, because if you had said negative and negative is positive, you'd have had a positive 9, and positive 9 and 2 would have been negative, and the whole thing would have changed up. It is coincidence if they came out to the same answer. Well, it's not coincidence. They came out to the same value at the bottom, so of course they come out to the same answer. But I just wanted to show you the difference. In this one, you could get away with doing the double negative first. If you did it first here, the answer would come out wrong. So be careful, y'all. These are 2 examples of subtle differences that trick students up. Be very careful. All right, let's wrap this up. Last thing I want to talk about is really more of the same, formula evaluation. There's just a couple formulas in the homework that use geometry. There's a couple formulas that use geometry. Actually, there was one other thing. Sorry, I'm jumping ahead. I wanted to say one other thing here. Let's do another function real quick. And this is something you should know already. I'm just going to bring it up in case you don't. This is one of those things that, a lot of times we assume students are good with, but over the years, I've kind of found out that that's not always the case. So let's say I gave you that function. The only thing I wanted to mention was, again, these lines, this absolute value. A couple of y'all have asked me about that. Absolute value just means whatever's inside can't come out negative. So let's say we said h of -3. Remember, this is the function h. This is what happens when you put in x. So what happens if I put in -3? We have our absolute value of 2 times -3 minus 4 over 3 times -3. So just don't worry, it's still the same thing as normal. Up in the top, 2 times -3 is -6, minus 4, that's -10 in absolute value. 3 times -3 is -9. The absolute value of -10 will come out to +10. That's what absolute value does. It makes whatever's inside positive. The bottom number is not part of the absolute value and would stay negative. So I just wanted to reiterate that. That can be a little bit confusing for people, okay? So just wanted to go over a quick absolute value question there as well. All right, so back to what I was saying a second ago, the end of the homework, there's a few geometry problems. We're not gonna have a big geometry lesson, and in fact, you guys will be happy to hear this, you do not need to memorize any geometry formulas, all right? You do not need to memorize any geometry formulas. Any formula that we require from you will be given to you, and I'll give you an example in a minute. What I do want you to know is when to use inches versus inches squared versus inches cubed. Or if they were meters, meters versus meters squared versus meters cubed, centimeters versus centimeters squared versus centimeters cubed, all right? Think about it. You need to know these, because if I sold you 1,000 meter apartment, that's a very different thing than 1,000 square meter apartment or 1,000 cubic meter apartment. This is a 10 by 10, if it will say it was 100 square feet, that's a fairly decent sized place, room anyway. 100 cubic feet is a prison cell. So you have to be really careful and make sure you know these. The easiest way to do this, and I'll use inches as my guide, but it could be any of the basic ones. If it just says to use inches, or when you're supposed to use just your basic measurement, inches, meters, centimeters, whatever, that's for perimeter, which is the same thing as distance, right? If you said, how far did you drive to Miami? You'd say, I don't remember what it is, but like, I don't know, 200 miles. You don't say miles squared. You don't say miles cubed, because it's a straight distance. So anytime you're measuring just perimeter or distance, it's going to be inches or miles or whatever, just basic units. You get to the squares, miles squared, inches squared, things like that, when you're doing area or surface area, which is still a form of area. Easiest way to think about area is floor space. I guess I should add interior floor space, right? So if you wanted to know interior floor space, if you wanted to know the interior floor space of your house, that's square foot. And that's why they sell apartments and houses in square feet, because they're describing the floor space to you, the area, right? When it would be cubed is when we're talking volume. And again, this is really more of an FYI. I just think an educated person needs to know this. Or air space, you could say. How much air fills the room, that's volume. So if they're asking you to measure something around, like, oh, what's the, how far around is this fence? That's perimeter, and you would just use miles or inches or whatever. If they're asking you for area or surface area, it's going to be cubed. Oh, I said that wrong. Squared. Let's back that up. Let's make sure I say that right. If it's area or surface area, it's going to be squared, meters squared, inches squared, miles squared, whatever. And if it's volume, the airspace in the room, how tall the room is, how much you could fit inside the room, that's going to be miles cubed, meters cubed, inches cubed. Okay? So quick example, just so y'all can see sort of what I'm getting at. Let's say I drew this, this triangle here for you, and we'll label it. Let's say these are 11 meters. This is 10 meters here in the middle, and let's say this is 7 meters down at the bottom, just whatever, right? And I asked you for the perimeter and the area. Now, there is no formula for perimeter. So that is the one thing you should not expect a formula on perimeter. Perimeter just means the outside edges, whether it's a square or a circle or anything. It's the outside. So for the perimeter, it's going to be 11, 11, and 7, right? The outside 11, the outside 7, and the other outside 11. We don't care about the interior measurement for perimeter because perimeter is outside area, or excuse me, outside distance. So 11, 7, and 11. So perimeter is pretty straightforward. 11 plus 11 plus 7, that's 22 plus 7, that's 29 what? Well, just meters, right? 29 meters. Because it wasn't square, we didn't ask for area, it wasn't volume, so it's not cubed, it was just perimeter, so it's just the regular unit, meters, inches, whatever. The area, we would give you the formula for it, because like I just told you, we will not ask you to memorize geometry formulas, even though I think you should know the basic geometry formulas for squares and triangles. An educated person should know that. So this would be 1/2 times the base, which is 7, right? Base is where it sits, times the height. Now, is that 11 or 10? Well, when we measure height, it's straight up and down, right? You don't measure someone's height when they're bending over or leaning over. So the height here would be 10. And be clever here. 1/2 of 7 is some decimal number. But what's 7 times 10? 70, right? You can multiply in any order you want. So 7 times 10 is 70, and 1/2 of that is 35. 35 what? Well, this was area, so this would be 35 meters squared. All right, so just a quick geometry example. There's just a couple in the homework. It's not something we need to spend all day on, but I just did want to kind of warn you about them because they can freak people out. Again, you do not need to memorize any geometry formulas. Hopefully you'd have them, but if we want you to know them, we'll give them to you, okay? The only thing you really need to be careful with is knowing the units, inches, inches squared, inches cubed, and knowing when to apply those. The most important thing I'd say on the whole lecture today, guys, is using the parentheses. Coming back to a problem like this, going through and making sure that when you plug in something for X, something for Y, something for X, something for Y, you use parentheses and you'll get it right every time. Okay, so hopefully that was a nice quick lecture, not too bad, and I will see you guys in the next one.